So, of course, why do we need data? Because we are making decisions based on a framework. And this framework is a logical framework for decision making. By the way, what is a logical framework? It's a systematic approach that we follow to make a decision. And because we follow the systematic approach, we have a stronger likelihood for the decision to be less arbitrary, to be more predictable, and in this particular case, to be science and evidence-based. And this framework that was adopted for food standard setting is what we call the food risk analysis paradigm. Food risk analysis was adopted in the 1990s, in fact, in 1995, as the basis of Codex standard setting. But in fact, it was used since the 1960s as the basis for the decision-making process. And risk analysis, not food risk analysis is not something new. It is, in fact, a system of making decisions that has been developed and has been followed for so many fields where risk is a key parameter for making the decisions, whether be it for space missions, whether be it in aspects related to environmental protection, for example, the management of chemical factories. So wherever there is risk, we use risk analysis as the basis. Now, of course, food have risks associated with them, and we use food risk analysis as the basis for the decision-making process. And we're going to be going through the way food risk analysis was developed and was presented in the Codex framework. Now, when you look at Codex texts, you will find that food risk analysis was included, as I mentioned, in Codex text in 1995 with the adoption of the first text that identifies the fact that food risk analysis is the basis for the decision-making process when it comes to food safety and nutrition. And this was further re-emphasized when the World Trade Organization was created, WTO, and when one of the treaties, one of the agreements of WTO was adopted, and that is the SPS agreement, the Sanitary and Phytosanitary Agreement. And we will see how risk analysis and the management of risk is mentioned as part of SPS. Now, when we look at Codex text, you will find risk analysis mentioned in a plethora of texts. The first one, as I mentioned, is the statement of principle concerning the role of science in the Codex decision-making and the extent to which other factors are taken into account. This text clearly gives a direction that risk assessment primarily is the source of the scientific evaluation, but then after that, we need to put other factors that will support the decision-making process. In 1997, there is another statement of principle that were approved by Codex and that were added to the appendix of the Codex procedural manual. And those are the statements of principles related to the role of food safety risk assessment. So you see, we defined the role of risk analysis. In 1997, we defined the role of risk assessment. And then we adopted in the procedural manual as well key definitions, which are the definitions of the various steps of risk analysis, risk assessment, risk management, and risk communication. And subsequently, what we worked on in Codex is that we said that these principles, not only should they apply for Codex, but they should also apply for member states. And that's how we came up with the working principles for risk analysis for application in the framework of the Codex Alimentarius in 2003. Now, the idea of following risk analysis is that we follow, as I mentioned, the systematic approach. We try to assess the risk, we identify the issue and the potential impacts of the issue, and then we formulate option for management. We try to evaluate the potential impacts of these options, and we select the most appropriate option. We implement it we evaluate it, and we redo the cycle again. It's a cycle. And basically, what this allows to do, it provides both Codex and food regulators with a systematic and structured approach that is to be followed to reach those decisions, primarily in this case, to protect public health from food safety issues. Now, as part of risk analysis, we have identified three components: risk assessment, which is the scientific component; risk management, which is mostly the policy component; and risk communication, which is really the interaction between the various partners and stakeholders while these two elements are taking place. So we have a definition of each of these components, and risk assessment is defined as the qualitative and quantitative characterization of the risk. So really, it's the estimation of the potential for adverse health effects to impact a consumer, to impact an individual, or to impact populations. Now, you have, as an objective of the risk assessment, also risk assessment is codified, and you have several steps in the risk assessment. You have to start by identifying what the issue is. You have a risk because the food contains a hazard. So you need to identify the hazard. Then we need to identify or to characterize the potential impact on human health of that hazard. And that's what the hazard characterization is for. And then the hazard and the impact of the hazard on health do not materialize unless we are exposed to the hazard. So we need to estimate what is the level of exposure, because that level of exposure is really related to the probability of the hazard to be inducing those effects. So that's what we do with the exposure assessment. And finally, when we combine the two aspects, the potential impact on human health, the potential exposure, and we combine those two, we reach what we call the risk characterization. Now, we will explore very quickly the difference between a risk and a hazard. So if I ask you in a very simple word, between the risk and the hazard, what is the parameter that I need to include? It's the probability. Or we can say it's the exposure, but the exposure is a representation of the probability. And the example of this representation is this. So you have a big wave. The big wave is the hazard, okay? And the potential impact of that hazard is what? Drowning, okay? Now, for drowning to happen, if you don't have a person in front of that wave, no drowning will happen. So the probability is really the probability of having a surfer by that wave. If there is no surfer, the hazard is there and it will not have an impact. Same situation here when we have this crossroads. The crossroads is the hazard. The potential impact of that crossroads is what? Accidents, right? But for accidents to happen, you need to have cars. If you do not have cars present at the crossroads, the impact of the crossroads will not materialize, okay? So, and we have another representation here. Now, speaking of food, if I take a capsule of cyanide, cyanide, as you know, is basically a white solid, so sometimes very difficult to distinguish, doesn't have really a taste. If you take that bottle of cyanide, it's locked, it's capped, it's locked, it's labeled, and it's put in a cupboard and it's locked away. So the hazard is 100%. The potential for that cyanide to induce an impact on my health is practically nil. It's very far away from me. I'm not going to be reaching it. It's completely out of reach, right? Capped, locked, labeled, and away. If I take that cyanide now and I put it outside, okay? So it's no longer locked. It's outside, but it's labeled. So, and I can see it. And maybe there is even this sign in front of it, you know, to tell me that this is not something that I should be using. So, of course, if I'm not a person who can read or maybe distinguish very well, I increased the probability. So the probability increased, but it's not very high. It's not equivalent to the hazard itself. The hazard is 100%, and the risk has increased because the probability increased. Now, if I can take the same bottle and I'm going to put it in the kitchen, where generally I prepare food, so I increased the probability of use, and at the same time, I did not put a label. So somebody might confuse it with sugar or salt, and therefore there is the potential for its use has increased significantly, and now my risk has increased. And finally, if I take that and I put it in my coffee altogether and I'm drinking the coffee, my hazard is equal to my risk because my probability has become 1. Okay? So this is just an illustration of the difference between the hazard and the risk. And again, you have definitions, and I'm not going to go through those in details. You have definitions that are including in the ISO standards for what a risk is. Now, of course, we are here in the context of preparation for Codex proceedings, so we need to recall the definitions that are used in Codex. You have a definition of risk assessment, and you have also a definition of the various steps of the risk assessment. So what I need to just actually focus on here is that the hazard aspect, both the hazard identification and the hazard characterization. By the way, what do I mean by hazard characterization? You have a full definition there. The hazard characterization is really the estimation of the potential impact of the hazard on my health, on human health. Now, if I ask you, is this characterization or should this characterization be different when I'm talking about it in Oman, in Tunisia, in the United States, or in Chile? Will it be the same or not? It's going to be the same. Why? Because we're talking about humans. It's the impact of the hazard on humans. And you're going to tell me, yes, but you know what? Humans have difference in their background. You have genetics that enters. You have the environmental considerations. All that is accounted for in the hazard characterization. When we do the hazard characterization, we take into account vulnerable population, including any genetic, influence, or including actually some vulnerable subgroups like infants, like immune compromised individuals. So all that is accounted for, which means that the hazard characterization is valid everywhere. For the exposure assessment, can I use the exposure that was done in France and say it's applicable directly here in Oman? No. Why? 2 factors that actually interfere in there. First of all, I have no indication that the level of contamination in France is the same as the level of contamination here in Oman. The second influence is that I have no indication that the food where the hazard is occurring is consumed in the same way in France as it is in Oman, which means that the exposure is the element that varies from one country to country. And because the exposure varies, the risk characterization will also vary. So you're going to hear me, and you hear all the colleagues throughout the workshop speak about always exposure is a product. Still doesn't actually allow me to move. I'm not really very lucky with I'm noticing this as actually statistics right now. Sorry. So basically, I'm just going to repeat that for exposure, it's the product of. So if I try to define exposure is the product of the occurrence of the hazard and the consumption of the food. Okay? Exposure is the product of occurrence multiplied by consumption. And we're going to be repeating that 300 times. Probably at the end, you're going to be dreaming of that during your sleep. You're going to be speaking about exposure is equal to occurrence multiplied by consumption. Okay? So Now, I'm just going to be saying a few words of differentiation between two terminologies, safety assessment and risk assessment. Risk assessment is the generic term. Risk assessment is really the scientific assessment trying to quantify and qualify the impact of a hazard on health, accounting for the general impact of the product itself, but also taking into account the probability of that impact to happen based on the occurrence and on the consumption. Now, as you know, for food, you have hazards that occur without you intervening in them, meaning contaminants. Contaminants, they are there, you do not add them to food. They are there in a non-deliberate fashion. And for those, you apply the word or the terminology of risk assessment. And risk assessment is, by the way, a general terminology applied for all. But when we speak about potential hazards that are introduced as a result of an application where you deliberately add the substance or you deliberately introduce a new food, like a novel food, in this case, we use the terminology of safety assessment. Why? Because I have a say in this. I have introduced the application. Example of applications that I have introduced. Additives. It's a direct addition to the food. As I mentioned, novel foods. In novel foods, I will speak about a safety assessment because, again, it's something that I deliberately created, like a genetically modified organism or a novel process, for example, like cold pasteurization techniques. You know, those are things that I deliberately introduced in the context of food production. Okay? Another example, pesticides. Pesticides are not added directly to a food. They are added indirectly because basically they are not meant to stay in the food. I added them to the crop in the context of agricultural practices. My hope, of course, is that they do not stay because basically we have withdrawal periods and so on, so that basically the pesticides diminish as much as possible, but you have residues that stay. Okay, and because this application is deliberate, I'm going to be speaking about a safety assessment. The same thing applies for veterinary drugs. Veterinary drugs are also added deliberately, but in an indirect fashion. I don't add them to food. I add them to the animal that is meant to produce the food. And as a result, also, they're not meant to stay, but you may have residues that might persist at the end after slaughter or after harvest. Now, of course, risk assessment, and particularly the aspects of exposure, will vary in relation with a number of other parameters. The fact that the food is processed or unprocessed may change the occurrence and therefore may change the risk. The fact that the food is transported, is conserved in a certain way, also will have an influence on the way the risk will be found. So you have a number of other parameters related particularly to the production, the handling of the food that may also influence the risk. And when you look at the data that you are going to be needing for risk assessment, you're generally going to be looking at data of two categories. Data that will inform the hazard characterization, and that's what you find in foodborne illness data, for example, epidemiological information, any type of toxicological studies. All those will inform you on the hazard, the impact of the hazard on your health. You have a second category of data that will inform you on the exposure. What are these data? Again, what informs the data on exposure? Occurrence and consumption. Okay, so that's really what informs the data on exposure. Again, the same type of information. All what you see on the right are data that will inform you on the hazards, dose response models, severity, magnitude of health effects, the impact on populations, and so on. That's what you find on hazards. What you see here on the left here, basically that's what informs you on exposure. Population aspects actually may inform both. because you may have vulnerable groups that you account for in your hazard characterization. Populations differences, that's generally what you see in the consumption patterns, and you're going to be seeing that in the presentation dedicated to that. You're going to be seeing in a population, people don't consume food in the same way. Even in Oman, you may have people that consume a lot of rice, others that might consume just a little of rice. So you may have differences in consumption based on subsets of the population. Now, of course, when we are estimating a risk, we are looking at combinations of foods and hazards. And generally, at this point, we are doing risk assessment in the context of a combination, one food, one hazard. That's the majority of risk assessments. That being said, we are right now improving methodologies in order to look at multiple hazards in multiple food sources and trying to actually get the potential impacts from that. Generally, when you have a hazard that can find itself in several foods. So for example, arsenic. Arsenic, you may find it in seafood, you may find it in rice, you may find it in some leafy greens. So if you want to have the potential impact of arsenic on health from food sources, you're going to be considering the exposure from leafy greens, the exposure from seafood, the exposure from rice, and you're going to be considering the addition of all that. Okay? So you take each food hazard combination and you add them in order to look at the potential impact for one particular hazard. Okay? That's how we do it right now. And we do not take into account at this point any synergetic or mitigating aspects. We will just basically add things up. Now, we spoke about the potential impacts of other factors that may influence your risk assessment, and particularly the way your hazard occurs in food. We spoke about storage, processing, packaging, cooking, the way you eat the food. All that may influence your exposure to the hazard. Now, looking again at, or going back to Codex, this is how the risk analysis process has been portrayed in Codex. And you see this representation where risk communication is the bubble in which both risk assessment and risk management coexist. That representation was not a fortuitous one. It was made on purpose. Why? This is to re-emphasize the fact that risk communication should happen at every stage of the process. When you do risk assessment, you do risk communication because you have to communicate the outcome of your risk assessment. Okay? You have to share it. You have sometimes to exchange information. Wow, I'm not going to be finishing in 3 minutes. I can tell you that. Okay, so, but I will try though to fast track. Thank you for that. And we have, I'm repeating basically the three components of the risk analysis now represented here. And again, really what we want to do is really to look at how this is addressed both in Codex and by national governments. So as you saw in your quiz or in the pre-assessment or in the pre-discussion, questionnaire, you saw that Codex is the risk manager, right? But who does the risk assessment for Codex? It's basically those entities, those expert groups, JECFA, JMPR, GEMNU, GEMRA, and ad hoc expert meetings. And those are the ones that produce the risk assessments that Codex committees will be using. Generally, that is done on the basis of a request and provision of advice system. So how does it work? When a Codex committee needs some scientific information, it will request for that advice from the expert bodies. Once the expert bodies conduct their scientific assessment, they give it back to Codex for use in the formulation of the risk management approach. Now, to be able to do this, this is where you need the data. Because for those scientific bodies to conduct their risk assessment, they need information. And if they are not provided with that information, particularly on the occurrence, they will not be able to provide their scientific advice. Or if they have scientific data that is skewed, meaning that most of the data is coming from Europe, from the United States, from Japan, from Australia, New Zealand, Canada, the risk assessment will become a risk assessment supporting the estimation of the risk for those populations that provided the data. So if you do not have data, you exclude yourself from the risk assessment process. And that's essentially what we want to mitigate, hopefully with more data being provided by Arab jurisdictions. I have to deduct all the time that, you know, this thing doesn't respond to me. Now, if we do this, c'est pas moi là, right? I'm going back. So now, if we go back to this with the with national governments and Codex, like we try to see how things occur when it comes, for example, to a veterinary drug residue. A veterinary drug residue, who does the risk assessment? At Codex level, it's JECFA. Even though JECFA is called the Joint Expert Committee on Food Additives, it actually does more than additives. It does additives, contaminants, even actually flavoring agents, and it does also veterinary drug residues. Now, who does that in governments? Who does that in governments? Your own risk assessment body will be able to do that, the risk assessment, okay? At the national level, you will be doing that within your own food safety authority or within your own competent authority. If I look at the decision of risk management for vet drugs, who does that? That's CCRVDF. We have a committee dedicated to veterinary drug residues, and that's the one that will conduct the formulation of the standard. And then who will be able to do the enforcement? Codex will not do any enforcement. Basically, the enforcement is set at the level of food competent authorities. I'm going to go to the next slide, please. Yeah, can you do, I'm going to ask you to help me with the next slides because this is not responding in an accurate basis. One slide back, sorry. So, of course, in Codex texts, we have basically a series of guidance documents that we must or we can rely upon in order to be able to give you direction on how you conduct the risk analysis process. You have the procedural manual, obviously. You have also the expert committees, so JECFA, GEMRA, and so on. They have their own procedural approaches that are fully documented and that go from the way experts are selected to the way data are utilized. Now, a lot of the aspects that govern the risk assessment process that expert bodies do in Codex are also documented in the procedural manual. So in the procedural manual, you will have principles for risk assessment for pesticides, for contaminants. So that's essentially the body of guidance that is used in order to be able to support the formulation of the risk assessment, but also the development of the risk management options. And of course, basically Codex issued a number of texts for guidance to governments as to how risk analysis can be applied in the decision-making process. The next slide, please. Now here, I would like to further re-emphasize on the importance of following the risk analysis approach so that countries that are members of the World Trade Organizations can fulfill their obligations vis-a-vis WTO, and mainly the SPS text. And you will find on Article 5 of the SPS agreement a clear direction that members have to ensure that their sanitary measures are based on an assessment of the risk. And here, of course, given that the SPS agreement is not only about food safety, but also about animal health and plant health, here we're talking about assessing the risk not only to humans, but also to animals and to plants. And of course, here we're talking about applying the best practices and the guidance that is provided by international organizations. It also directs us to use the best available scientific information and evidence in this regard. And when they use the word evidence, by the way, they use that just to emphasize that evidence is used for risk assessment, but also for risk management, because when you are speaking about a potential impact on the economy, you have to support that with data and with evidence. You cannot be doing that simply on the basis of conjecture. The next slide. Now, on Article 5 here also, you will find some direction about conducting or formulating risk management decisions. And basically, the direction is that these decisions or these options need to be developed while taking into account to minimize the potential negative impacts on trade. And finally, basically, we're calling on countries that they should avoid any arbitrary decisions that may be unjustified. So again, arbitrary decisions are those who are not supported by a food risk assessment when it comes to decisions related to food safety or nutrition. Now, of course, in our discussion throughout this workshop, we're going to be focusing on the risk assessment, and we're going to be focusing primarily on the bubble on the right here, the exposure assessment aspects. The next slide, please. And here we have a different representation of the way the risk assessment is conducted. As you know, the finality of the risk assessment is what we call the risk characterization. Aspects related to the hazard, as we said, those are applicable everywhere, and we can use JECFA, GEMRA, and so on as the basis for the outputs of the hazard characterization. Now, sometimes some countries may have a different outcome of the hazard characterization, and that may be resulting from the fact that they have applied, for example, a different level of protection. Okay, and that's possible. That's possible. You may, for example, also take into account of the uncertainties in a different way. So you may have sometimes differences, but these differences generally are justified by a difference in the risk assessment policy of the country. But generally, when you have a risk assessment, and particularly a hazard characterization of that risk assessment developed by an international organization, that tends to be applicable everywhere. What varies is, of course, the exposure. And no, it's okay. And again, what varies, what makes really a risk assessment that is conducted by JECFA not necessarily completely applicable without changing or without any adaptation, what makes things change is the exposure. So we go back to the next slide. No. So basically, what is geography dependent? We go back. It's the way foods are consumed. People don't consume food in the same way, and that can influence the exposure. The second, of course, influence is the accurate representation of the occurrence data. And again, monitoring program shows you that contaminants do not occur with the same pattern everywhere in the world. And that's totally geography dependent. And that's what we need to ascertain in your own national risk assessments, but also for risk assessments that are developed globally. To be applicable globally, we need these to be made available with the global representation. The next. So again, here you have different sources of data for the two aspects. As I mentioned, for the hazard characterization, you have epidemiological data, but also toxicological information. The next slide. For the exposure assessments, you're going to be needing data that is provided mainly by yourselves, mainly data on the occurrence of the hazards in food, your monitoring studies, your total diet study programs, any type of information related to your enforcement activities and your findings, but also your food consumption information. And we can find this information not only in governments, but also we can find information in the scientific literature, because there's a lot of research that is conducted on both aspects, the aspects of occurrence, but also the aspects of consumption information.